Right, so by show of hand, how many of you are new to microservices? Some of you, yeah? And how many of you think you need a better software architecture? I was hoping more hands, but yeah, that's good. So while we're here talking about microservices, we're seeing a lot of customers that adopt the microservices have managed to achieve benefits like increased pace of innovations and also improve on customer satisfaction. So we have lots of content to go through, so I will ask you to leave your questions to the end, and I'll make sure we have time to cover them. My name is Kevin Huang. I'm a solutions architect for Amazon Web Services, AWS. I've been with the company for 2.5 years. I started my AWS career as a professional services consultant in Australia, so excuse my accent. Yes, it's. Have I lost it? Okay, and I help Australian customers embracing DevOps. So I hope by the end of the presentation, you will walk away with a set of design principles that you can apply and personalize microservices journey, and also consider AWS to make that architecture transformation from where you are today to where you want to be easier. So let's begin by talking about the monolith. And when I see the word monolith, I can think of the Death Star in Star Wars, right? Any Star Wars fan? Okay. The Death Star, you know, that gigantic, complex machine and with lots of tightly coupled systems. So monolith can be a good way when you're starting out because it is the simplest form of architecture and enables you to get that minimal viable product out the door and get you to the market quicker. In fact, Amazon.com started out as a one big monolithic application with running a web server, talking directly to the backend database. Now, of course, when your application or your company grows, monolith begins to slow you down, and that's exactly what happened to Amazon.com website. I think it was around year 2001. We added so many features to our website that the code base was written over those, I believe, began to sprawl. And we then realized that the monolithic architecture was the biggest bottleneck. Our developers couldn't integrate any more new features to the website, and they had difficulty in understanding the data coming through from our e-commerce operations, and also they couldn't respond to the customer feedback quickly. So you're probably wondering, so what did Amazon do, right? Before we talk about that, let's look at the challenges that you typically go through when you're dealing with monolithic software. Right. So first thing is difficult to scale. The parts of the application that you want to scale independently, typically they tend to share resources with other parts of the application you don't know about, and you tend to have long build, test, release cycles, and people are just afraid to add new features because they don't know what the impact will be to other functionalities. And operation is a nightmare because there is no isolation within a system, so which means there's no clear ownership. And the monolithic code base is big, and it's hard to maintain and evolve because when you touch it, you touch the monolith as a whole. And there's not much of a developer freedom, which means innovation would take a long time, and then you don't respond to your customer feedback. So the lack of agility, the lack of innovation, what do you end up with? Frustrated customers. Right, there's another thing, the monolith development lifecycle. So when you have so many developers, let's say hundreds or even thousands, and they all try to push changes down to that single shared release pipeline, you can expect there will be a lot of frictions in every point of your development life cycle. So during your development, your engineers will have to coordinate changes, and they will have to make sure whatever features or changes they put in break someone else's code. And also if they want to, say, upgrade a share library to take advantage of new features, They need to convince other people to do. Good luck with that. And if they want to push a fix to a new feature, they need to merge the change in with other people that are in the process of changes. And that leads to something we call merge Fridays or merge weeks, if you're familiar with that term. And basically, all the developers will spend the whole day testing, compiling, and making sure they're ready for the next release. And when you're lucky enough to make it out of the development lifecycle, you have another overhead, which is pushing that changes down to that shared release pipeline. And what happens there is you run a lot of tests, lots of testing, automated, manual, and just to make sure that there are no regressions. And then you have to deploy that entire monolithic application into production. So, okay. So to give you the size of the overhead, Amazon used to have a central team whose sole job was to push that or deploy that monolithic application into production. So if your company is going through growth, you try to innovate and compete, this type of sluggishness is just not going to be acceptable. And I touched on the term sampling earlier. So typically we see a monolithic design pattern that enables you to do software coupling in two common places. One is shared libraries, when two teams are sharing each other's library and plus some common libraries. And what happens is when one team makes an update to the library, automatically breaks the other team's code. Or it was like if the team is doing their software builds, but they got blocked because they don't have the latest version of the other team's libraries. And the other is at database schema level, so both teams are sharing database schema. And again, one team updates the schema by adding a new column. That would break the other team's code. So now that you understand the challenges with monolithic software, it's no surprise that Amazon.com decided to implement a mandate to decompose the monolithic application and evolve towards microservices, a share nothing architecture. Let's talk about microservices. If you want to look up the definition, you can go on Wikipedia, but personally, I like the definition from our Vice President of Cloud Architecture, Adrian. So, according to Adrian, microservices is service-oriented architecture composed of loosely coupled elements that have bounded context. So service-oriented architecture means that you're building with many services, and all these services communicate each other over the network to fulfill a goal. And they are loosely coupled. It means that they independently, sorry, the microphone is going in and out. And they all have bounded context. So what that means is they are all self-contained. They can coexist independently and have their own release cycles. So what does a microservice look like? It has a data store, and it can be a relational database management system or a NoSQL database. And your application logic, your business logic, sits in somewhere and represented by your code or libraries. And you expose that application logic through a set of public APIs. Could be RESTful APIs. So by way of design, microservices let you avoid software coupling. Because now they're all self-contained, they're all independent from each other, and the way they communicate is by each other's public APIs. And as your company grows and your application grows, you may start having an ecosystem of microservices. So here is just an example at a high level what our ecosystem will look like. This is showing you building a restaurant application, a restaurant nearby you, for example. You start out with a restaurant microservice, and then you might consider, let's add location, Let's add ordering microservice and payment and so on. So all these microservices all collaborate with each other and talk to each other by the public API to provide a application functionality. And in fact, that's exactly how Amazon works. So all these things that you see, like customer feedback, shopping carts, title, reviews, whatnot, they all, many microservices all talking to each other and ensuring that when you shop on Amazon, you have the best experience. And that's a shipping container. I didn't know what it was until I looked it up. I don't know why anybody wanted to buy a shipping container. And it's at a bargain price as well, by the way.
Free shipping.
Yeah, free shipping too. So now we talk about microservices, what it looks like. So you're probably wondering, if I move to microservices, what does the success look like? There's many ways to measure success, but here's one data you can use. So suppose you have thousands of development teams, they all creating highly factored or refactored microservices, and they deploy that to dev, test, production environments in a continuous delivery process. And what you get is a lot of deployments. In fact, 15 million deployments a year, and that's what Amazon managed to hit in 2014. And if my math is any good, I think that equates to 1.5 deployments every second. 1.5 deployments every second. It's a lot of deployments. Anyone here heard of Guild? Cool. Thank you. I was hoping someone would. Guild is a company that sells luxury designer brands online, and they at last year's reInvent about their journey from monolithic to microservices. And something interesting about Guild is that they have sales on every day at noon, Eastern Standard Time. And when the sales go live, typically their traffic just spikes by 100 times than normal within a matter of seconds, right? And they used to run a monolithic application written in Rails, and that monolithic application just couldn't scale to support this type of burst of activity. So then they made a change to the architecture to move to a distributed system based upon hundreds of microservices all running on AWS. Now, so if you think about what approaches you can take to build your microservices applications on AWS, I'm just going to go through a number of services for you to consider. The first one is API gateway, and it's quite an easy way to deploy your microservices. When you publish your API, you publish it across all our worldwide edge locations. So the benefits of API gateway is, well, it caches your content. So it can actually increase the responsiveness of your microservice using cache. And it gives you traffic throttling. So it avoids your backend system from being overloaded. And all the API calls and activities that get logged to our Amazon CloudWatch, which is our monitoring service. And it integrates with Lambda functions. So in fact, API Gateway can abstract your backend. So your backend can be running in Lambda, on EC2, or even ECS, our container service offering. And you can run multiple versions of the same API, which means it gives you the ability to make changes to your API, using different versions. And it's fully managed, means you don't run any server, high availability, for all this taking care of for you. Elastic Compute is our compute offering in the cloud. You have complete control of the amount of CPU and memory. And it reduces time to obtain and boot new server instances because you can boot the server from Amazon Machine Image or AMI that you owned or you purchased from our AWS Marketplace. So with AMI, you have all that information to run a software. And right. Oh, good? Yeah. So the AMI has all the information and configurations you need to run your software, so you can boot up your server instance in a matter of minutes. And we have many different type of instances, ranging from compute to storage optimized, memory optimized, graphic optimized, and depending on your use cases. And you only pay for what you use. Now I mentioned about our container management service offering, ECS. It's a high-performance container management service for running your Docker containers. It has a built-in scheduler, and so you can use the built-in scheduler to spread your Docker containers across availability zones to have high availability. But you can also write your own scheduler if you are for the challenge, or use third-party scheduler. Like other services, ECS integrates quite well with the rest of the ecosystem on AWS. For example, Elastic Load Balancer and Elastic Blocks Storage, which is our persistent storage. There is no additional charge for using ECS, and we also offer a container registry service called ECR that you can use to maintain, deploy your Docker images straight from that registry. So I mentioned about Lambda. Lambda lets you run code without managing servers. So how it works is you upload your application code to Lambda, and that can be written in compiler languages like Java or .NET, or interpreter languages like Node.js and Python. You upload that to Lambda, and then you set the Lambda function to be triggered from other services. Yeah, there we go. Okay, cool. So I hold it somewhere properly. And Lambda will scale for you. So if you keep a Lambda function stateless, AWS Lambda will replicate your functions to scale according to the incoming events. And as I mentioned, you don't need to provision any infrastructure, and you pay only for what you use. And it comes with sub-second metering. DynamoDB is our NoSQL database service offering. It's capable of handling any amount of data. So behind the scene, DynamoDB will provision machine resources and to make sure it meets your storage requirements. It's highly durable. So again, DynamoDB will replicate your data across 3 facilities within a given AWS region. And it's using SSD storage, and simple and cost-effective. Right. So if you're thinking building a microservice application in AWS, a typical architecture, like leveraging some of the services I just mentioned, will look like this. And what you need to start with is looking at the flow of your API call, starting from your left. Right. You have your clients. That could be mobile apps, web apps, or some backend servers. And the request will first hit our CloudFront edge locations. And then CloudFront will then reroute that request to the API gateway in your customer's region. And API gateway will first look into its cache. If the record is not there, what it does is it broker that request to the backend where your application logic is running from, and that could be Lambda function or EC2 or ECS. And then your backends, your microservices will then talk to the DynamoDB, for example, and then return that content back to the client. And all these the API calls will get logged into our Amazon CloudWatch monitoring service. So I know a company called TrackTax, and they actually built their microservices just by using the serverless approach. And the serverless approach is actually a good way to think about microservices at the start. And that company is able to get all the benefits of microservices and still be able to keep a team of less than 10 today. So we're going to switch gear and talk about some of the best practices we have seen. I mean, different companies have something that works for them, but these are some of the big ones. Firstly, microservices only rely on each other's public APIs. So I mentioned this multiple times now. So you have two microservices, and they should really talk to each other by the public API. So if service A wants to talk to service B's data store, that's an anti-pattern, right? So you always have to talk to the other service's API, even if you want to get the data. And you should also think about evolve your API in a backward compatible way, and then document and communicate during upgrades. So what I mean by that is you should think about some kind of versioning strategy. And here we're just showcasing one of the strategies. It's called semantic versioning. And the reason why you want to have a versioning strategy is because if you think about the public API, it's actually a contract between your microservices and its client. So once that API is released, you need to keep it maintained as long as your clients rely on it. So if I'm going to make a change to the API, say going from version 1.0 to version 1.1, that's considered a minor version change where I'm adding a functionality in a backwards compatible way. But if I'm going from version 1 to version 2, that's a major version change. And that's backwards incompatible API change. And you may probably have patches, and patches in terms of versioning has to be backwards compatible as well. Right. The second best practice is use the right tool for the job. And I mentioned earlier, microservices are all independent from each other. They're self-contained. So here, service A, again, talks into service B, and service A may be passing some data over to service B to store that information. And it doesn't matter, like how service B wants to store that data is completely up to what is the right fit for your business. So if you think NoSQL database like DynamoDB makes sense, use DynamoDB. If you want to add a search component to your microservice, you may consider our Elasticsearch service, which is a managed service offering running Elasticsearch in the AWS cloud. And if you're storing structured data, like completed customer orders, then it might make sense to use a relational database, like RDS Aurora. So when it comes to programming frameworks, you should also embrace polyglot programming frameworks. So what that means, I think it's coined by a guy named Neil Ford, who says that when you develop applications, you should consider using multiple different programming languages because different languages are suitable for tackling different problems. So if your team is comfortable working with Java, use Java. If they're comfortable using Node.js, use Node.js, right? So use the right tool for the job is the key. And the next best practice is secure your services. Now, this whole slide is talking about security, and we can have a very extensive discussion on security, but the way I like to think about it, security is not unusual or any different in AWS. By that, I mean you have to think about defense in depth, right? Apply defense at every level. And on AWS, we have features that are available to you to do that free of charge. And you can look at network level security like VPC, Virtual Private Cloud, security groups, network ACLs, and encryption. And you can also apply IAM policies to lock down who has access to what in AWS. And there are other features at the server and container level as well as the application level that you need to consider. And whenever possible, leverage managed service like API gateway as a front door for your microservice. because of the reason I mentioned before about API throttling. So API gateway can protect your backend from being overloaded by traffic. And also API gateway can help you to prevent against DDoS attacks. And when you think about authentication authorization, you need to do that everywhere as well. So either that's from client to service or service to service. API gateway supports custom named authorizers, which allows you to implement different verification, authentication, authorization strategy like JSON wait tokens or OAuth. But you can also use IAM-based authentication with API gateway, which allows you to define a policy that grants specific privileges that your microservices need to do its job. And secrets management, you can store secrets in S3 buckets. You make sure you encrypt it before you upload to S3 or use server-side encryption available from S3. And then also apply IAM policy to control who has access to that secret. You can also use other open source tools if you want. And last but not least is be a good citizen within an ecosystem. So by that, I mean, communications is the key as you continue to grow your microservices application. So here we have a service A and B, and service A is asking B that we need to call your microservice to fetch restaurant details. And service B will pose back a set of questions to A that what APIs you need to call, what permission you need, and also what are your request response limits. Right. So really, if you think about it, you need monitoring, you need logging, you need tracing. And the principle here is if it moves, you should log and track, right? But what I'm recommending you to do is spending more time on analyzing and understanding the metrics that you are collecting and making sure there's a clear alignment between your business goals and your microservices. So, for example, if your business or customers, they care about how easy it is to use a single-click ordering, like you can do on Amazon website, then if that functionality is slow to respond, your customer is not going to use it. And one way of understanding that alignment is to come up with shared metrics. And here I'm just giving you a couple, like request time, time to first byte. But again, it's understanding what really matters to your business and customers. And you should also consider collecting user experience metrics like status codes, latency, and there are distributed tracing tools on the market that you can use to trace the flow of the API requests. So use that to your advantage. Okay, so finally, I think the journey from monolithic to microservices it's not easy. You need to expect a lot of challenges, and also it requires additional work, both technically and culturally, to make microservices a success. And I'm just outlining some of the challenges here. So first, you need to understand your business domains, all right, and factoring in complexities like service discovery, eventual consistency, and also anticipate there are lots and lots of moving parts that requires you to increase your coordination effort. And also, it will, there's a complexity around testing, deploying, and really, it's an architectural transformation, but it is also a cultural transformation. So you need to think about how your team operate and how they solve problems as they go. Okay, so we cover today the evolution from monolithic to microservices. We talk about why companies of all sizes are adopting it, because they're seeing the benefits of faster implementation and improved customer satisfaction. So if you're thinking about microservices as the right architecture for you to going forward, we have a lot of resources available. But if you have any questions, I'm happy to take them. We also have architecture booth at the front when you're walking to your right. So if I can answer your questions now, please go and ask one of our architects. Any questions? It's good? All right, thank you.